way we have converted this given function of x into its inverse function. X is equal to f inverse of y. We Hi everyone, welcome to daily practice. In this video, I am going to explain you each and every step of the solution for the question that you can see on your screen. I urge you to watch this video till end, and if you face any doubt, you can share it in the comment box or you can DM me on my Instagram. And if you are new to this channel, subscribe it. Now, without wasting any time, let's start solving the given question. Find derivative of function y is equal to f of x. So this given function is y is equal to f of x, and using derivatives of inverse function, we have to find the derivative of this given function. So what exactly we have to do? You can see that this y is equal to f of x, which is equal to e raised to 2x minus 3. Now this is the function of x. This y is function of x, and we have to convert it into its inverse function, which will be x is equal to f inverse of y. So the given question will be in terms of x, and then its inverse function will be in terms of y. So we have to convert the given function into its inverse function. Now how to do that? Let's see. Now we have y is equal to e raised to 2x minus 3. Now what I will do? I will write this in terms of y. Now how to do that? Now here you can see that y is equal to e raised to 2x minus 3. Now this is exponential function. So I will use here laws of logarithm. So what I will do? I will take log of both the sides. Log of y is equal to log of e raised to 2x minus 3 to the base e. Now once I take log of both the sides, I will simplify this. Log of y is equal to this 2x minus 3. I will take ahead of log of e to the base e. According to logarithmic rules, this log e to the base e will become 1. So 2x minus 3 into 1, that is equal to 2x minus 3, which is equal to log of y. Now I will shift this 3 to another side. What I will get? 3 plus log y is equal to 2x. Therefore x will be equal to 1 upon 2, 3 plus log of y. So in this way we have converted this given function of x into its inverse function. X is equal to f inverse of y. We have just used laws of logarithm and converted this f of x into f inverse of y. Now once we get this, we will differentiate this inverse function with respect to y. So differentiate with respect to y, then what we will get? Dx by dy is equal to 1 upon 2. Now derivative of 3 with respect to y will be 0 plus derivative of log y will be 1 upon y. I will mark this as equation number 1. And then from equation number 1, I will put the value of y in this equation. Then what I will get? Dx by dy is equal to 1 upon 2 into 1 upon y. That is 1 upon y is e raised to 2x minus 3. So e raised to 2x minus 3. Therefore, on simplifying this, what I will get? Dx by dy is equal to 1 upon 2 e raised to 2x minus 3. Now we have to find derivative of function y is equal to f of x. So what I will do? Using derivatives of inverse function, using theorem of derivatives of inverse function, what I will get? Dy by dx is equal to 1 upon dx by dy. Now I will substitute value of dx by dy, which is 1 upon 2 e raised to 2x minus 3. 1 upon 2 e raised to into e raised to 2x minus 3. Now on further simplifying, what I will get? Dy by dx is equal to 2 into e raised to 2x minus 3, which is our required answer. So in this way we solve this given question. The most important steps in this question is to convert y is equal to f of x into x is equal to f inverse of y, which is this is inverse function of this given function y is equal to f of x. So how we have converted this? By using logarithmic rules. Once we get the value of dx by dy, we have find out the value of dy by dx using derivatives of inverse function. If you have understood explanation for each and every step that I have provided in this video, give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. If you have any doubt, you can share it in the comment box or DM me on my Instagram handle. That's it for this question. See you in the next video. Till then, keep practicing.